I'm Elian Saint-Hilaire, and in this video we're going to talk about Mesh Central's new Web Relay feature. Mesh Central has been able to redirect ports, TCP ports, from one machine to a remote machine or a remote destination on a different network for a long time. And we've been using Mesh Central Router to do that. In this video, I want to talk about a new feature called the Web Relay that allows you to do web page redirection without having to use the Mesh Central Router. So let's take a look at that. So I'm going to start with a few slides here, and I'm going to start with what you would typically do with Mesh Central Relay. So here I have a slide with Mesh Central at the center. On the left side, I have your typical user who has a browser, and he's browsing Mesh Central. And then he wants to access a web page that's on a web server somewhere on a remote network. So now you don't have VPN here. But you do have a mesh agent running on one of the computers of the remote network. Now, sometimes the web server is also on the same computer as the computer running the agent. So that's perfectly fine. And sometimes it's not. Sometimes the agent is somewhere on a remote network and the web server is also on a different machine on that remote network. Regardless of the configuration, usually what you would do is you would use Mesh Central Router to port map a local port on your computer to the remote port on that web server. And so you set it up. Usually you can do it with a single click for a lot of different things, or you can download Mesh Central Router and you can run it, log into your Mesh Central instance, and then you port map a protocol, for example, HTTPS, a local port to a remote port on a remote machine. And what happens is that when the browser accesses the local port, the Mesh Central infrastructure will tunnel that connection so that the agent will basically do exactly or mimic what the browser is doing on Mesh Central Router. So when the browser opens 1, 2, 3 connections, makes HTTP requests, then the agent will mimic that and will open 1, 2, or 3 connections to the web server and will send those same requests with the same data, get the answer back, and then send that through the infrastructure back to the browser here. Now, by the way, for security, people will ask, well, what's the security here? Well, the entire infrastructure is HTTPS protected. So between the Mesh Central Router and Mesh Central, the server, and also between the server and the agent. So all of this is encrypted, and the browser could do HTTPS, it could do HTTP, but either way, that will get forwarded. If the browser does HTTPS, then it is an end-to-end encrypted connection. So the infrastructure will basically forward TLS or fully encrypted traffic between the browser and the server. Now, if the browser just does HTTP, no TLS, then basically the TCP connection will be forwarded. It will still be forwarded encrypted, but if the browser does TLS, it's basically double encrypted through the infrastructure. But in the end, it is end-to-end TLS if you're using a browser here. Okay, so one of the questions that people, or one of the features people have been requesting is, well, I have a browser browsing Mesh Central anyway. Why do I have to use this Mesh Central Router? Why, in the case of RDP, VNC, other protocols, it kind of makes sense to have this. But for HTTP and HTTPS specifically, I have a browser connected to Mesh Central. Why do I have to use this middle piece here? And so this is a little tricky, but because the remote web server kind of doesn't expect to be embedded inside another web server, so for example, you don't expect a web page that's supposed to be accessed from the root path to be embedded in a path of another web server. And usually that will break the web pages. So you can't do that correctly and route web pages. So what we're going to do with this new feature is we're going to create a new port on Mesh Central, and we are going to have the browser redirected to the new port, and this port will then be programmed dynamically depending on the settings you set. It will be programmed to relay to a specific agent and target. So we're going to have basically the same functionality as the Mesh Central router, but it's now going to be built inside Mesh Central itself. Okay, now the thing is, Mesh Central is a multi-user server. It can be multiple users using Mesh Central at the same time. And so at least initially, this feature will only open a single port, a single new port, and then depending on the cookie that you put inside the browser here, it will target a different target. So you can have multiple users using the web redirection port at the same time and targeting different machines and different web servers, and it will all work simultaneously from the same port. So let's take a look at how we're going to do that. So normally there's a redirection port of Mesh Central, which is the port 80. It's HTTPS. We call it the redirection port because everybody who hits it usually gets redirected to the main port. So this purpose is to just redirect the traffic to an encrypted port. It does have some occasional other features or other uses like Let's Encrypt and so on, but that's fairly simple, and the default port is 80. You can change that. The main port is 443, but now we have this new port called a relay port, and it doesn't have a default port assigned. So it is off by default, and you will have to turn this on. And you'll have to turn this on by going into the settings section of the config.json and basically type relay port and set a port. For example, in this case, I set it to 453. Now, obviously, it has to be a different port than the redirection port and the main port. And also, this port will have to be externally visible. If you're going to use this, you have to make the port 453 or any port you select, you have to make it externally visible so that your users' browsers can hit that port. Now, otherwise, the relay port will be configured about the same way as the main port. It will use the same TLS certificate. It will use the same DNS name. And if you use a Nginx, basically a reverse proxy in front of Mesh Central, then you'll have to configure the relay port exactly the same way that you would do the main port. So it's like as far as the infrastructure in front of Mesh Central, the main port and the relay port are kind of identical. So if you do TLS offload and you don't do TLS on these ports because Nginx does it, then both the main port and the relay port will not have TLS, and you'll have to have Nginx do it. Okay, so you open up this new port. Now what will happen is that, actually I'll skip to this slide here. What will happen is that you'll see new links in the device general tab of all the devices, or most devices. And it will say HTTP and HTTPS on these two links. And when you click on it, it will open a new tab in your browser, and you will see the web page of that device. So if you have an HTTP or an HTTPS server on that device that you're looking at on the screen, you can click on it, it will open a new tab, and you'll see the web page that is served by that device. And so internally, what goes on is that Mesh Central will push a cookie to your browser, and this cookie has the node ID that you're willing to target, you want to target or relay through. It will have the IP address of where you want your sessions to be routed to. And sometimes what we'll do is if the web server is on the same device as the agent, then the agent will be obviously the node ID. The address will be looped back to 127.0.0.1. The port will be either usually 80 or 443. That's the port you want to hit on the web server, and then TLS or not. And that's whether you expect HTTPS to be running on the remote side or not. And so that's what happens. You get a cookie pushed into your browser. Then your browser is opening a new tab on port 453 in this case. That's the port I set. And then the browser will open a connection. And of course, that port is always HTTPS. Even if you're accessing a HTTP server on the remote side, you're always going to have the browser do HTTPS here. And then the relay port will look at the cookie and the path that the browser is asking for, and it will format a request, send a request over to the remote web server, get the answer back, and forward that response back to the browser. Now, there's quite a bit of machinery here, because the relay port is not just port mapping, the TCP port over to the web server, the remote web server, like MeshCentral Router does. Here, what happens is that the relay port code is looking at the request the browser makes, fully understanding the HTTP header, the body, what the browser is trying to ask for, and then it turns around and opens a TCP connection to the target, and then it formats, it crafts a new HTTP request through that TCP or that TLS channel, gets the answer back, takes the answer back, and turns around and sends it back to the browser. It will try to stream. It does support WebSockets, so if the browser opens a WebSocket, it will do that. And the thing that's interesting is that even if the web browser is opening multiple connections here, the relay port code will create a new session for you, like a new HTTP session, and it will forward through that session. And so you may not have an equivalent number of connections on the left and on the right. So for example, you can have the browser here have no connections to the relay port, but the relay port's internal state still has open connections to the server, or vice versa. You could have more connections here than you have from the relay port to the server, because it's really like the relay port is acting like a completely new HTTP requester to the server. And so that's pretty tricky. There could be still bugs in here, but it seems to be working fine so far. The other thing that's funny or interesting from a security point of view is that if the server, the remote web server, sends a cookie back to the browser, then normally what will happen is that if the cookie is marked as HTTP only, that means it can't be accessed by the JavaScript of the browser, then what will happen is that the cookie will be kept inside the internal session of the relay port, and it will not be forwarded to your browser. So what will happen is that you may get a session cookie saying that you're logged into your router or something like that. So you have a home router, for example, and you log into that home router. The home router may give you a cookie, but you'll never see it on the browser. It will be kept inside the session here. And then every time the browser makes a request through the relay port will add that cookie and send that over to the server. So that's another interesting point here. If the cookie is not marked as HTTP only, then it's possible the cookie could be read by the local JavaScript on the web page, and so the relay port will forward that cookie over to the browser. But if the browser sends any cookies, those cookies are not forwarded. It's kind of weird, but that's the way it's worked so far. And so it's pretty good. So the performance so far is pretty good. I mentioned also HTTP streaming. If you are requesting a very large file on the other side, then the relay code will not wait to get the entire response before starting to send it or streaming it back to the browser. It does support streaming of responses back. It also supports HTTP chunking, content length. So I've done quite a bit of testing on trying to support like the basic HTTP 1.1 protocol, through this relay. But because you only have one relay port, then you cannot open multiple tabs to multiple targets at the same time. You can actually do it if you have different browsers. So weirdly enough, if you're logged in as Chrome and Firefox, and you take those two browsers and you log into your account, and you can use the same relay port to target two different web servers on the other side, and it will work. You'll see two different tabs with your two different targets, even though the two browsers are connected to the same relay port. And that's because the relay port here issued different cookies to the different browsers, and so they will see the different pages. So hopefully that makes sense. The other thing is, if you are not logged into Mesh Central and you don't have the login cookie that allows you to access Mesh Central, if you don't have that master cookie that shows you're logged into the server, then that relay port will refuse all of your requests. So this is pretty good because the relay port is pretty secure, and it can be used by many different users and many different browsers at the same time. So you don't need to kind of expose a large range of ports externally through your firewall or proxy. Just one port will do. Okay, so that's good. And so in the end, what the users will see, two additional links, and then the relay port, you can click on it and just see the remote web page. So let's see how this actually works in practice. I'm going to bring up my trusty developer server here. Now I am running it just inside the command shell like this, --admin as usual, so that I don't have to log in, and I'm already logged in. And so I see my devices. Now, my computer that I'm on right now is called Central. That's the one you're seeing here. And so one thing I can do is click on Central, and you'll see here the HTTP and the HTTPS links. And if I click on HTTPS, what will happen is that I'll access my own Mesh Central website. So this website here will be accessible through the Mesh Central relay port. If that makes any sense, I'll click on that, and boom, that's what we're doing. We have access to Mesh Central through Mesh Central. And then you'll notice also that Central now has this routing connection, because this web page here has a WebSocket through the infrastructure. And then if I click the little garbage can, I can cause this web page to disconnect. And so that's good. And then I can connect back again, and there we go, I'm connected again. Okay, so that, and if I close, yeah, then you'll see here it got rid of the session. So that's good. Another thing I can do is I can access, of course, HTTP for any of the devices. Here I have HTTP links, but this computer AMT15, which is actually on my left right there, it doesn't have a web server on it. But I can also, this entire technology works for local or relayed local groups. So here I have a device group that is, and if the way I created it is I went to add device group, I created a no agent devices relayed through an agent. So that's the group here that will create this group. And then I added my home router. So router has been added as my address, 192.168.2.1. This is the address of my router. And then I've taken this entire group and say relay through AMT15. So what happens is that any of these devices, if I try to access them, it will go through AMT15, my machine on my left, and then to the target, to the router. So here I'm going to click on HTTP, and I see I have a OpenWRT router. I can log into it. There we go. And you can see the web page. I can click on the system. services, network interface, and so on. And you'll see everything works. And as I'm doing this, this device doesn't show any connections, but AMT15 here is seeing a connection. And that's because I'm accessing this web page through AMT15 to my router. And of course, I can disconnect it if I want. I'm not going to do that. Now, of course, I'm doing HTTP right here. So I'm going to go back to this router and say HTTPS. And the router already does have an HTTPS port, so it can fully work. And well, there we go. In the future, I may have a web page that has to pop up for you to confirm the remote certificate. So right now, I just accept any certificate on the remote side, but that may change in the future. I may, when you do HTTPS, if the certificate has not been approved for the session, then you may get a prompt here to approve it before it's it works. Okay, so hopefully that was clear. The way that the mesh, the web relay feature works is kind of complicated, but in the end, I think users will really benefit from it because just one click, see the remote web page, super, super convenient, and hopefully really useful. Thank you very much and have a great day.